What's going on, everybody? It's Mr. Diamond, and we're going to be talking a very short introduction video that you could, I guess, count as notes for relative velocity. There's going to be a second video attached on this same location that's going to be me working out the example problem that's going to go with this that'll probably make a lot more sense. So relative velocity is going to kind of allow us to take into account multiple different, two-dimensional at least, velocities, and we can combine their vectors together to figure out more information about what we're talking about. This is going to make a lot more sense on the example we're going to use, but the only thing to get across before we get there is that we use subscripts to describe things in relation to one another, and this will make more sense in the example. So let's say you're in a bus. You're traveling 20 meters a second down the interstate. You are currently at the very back of the bus, and you start to walk towards the front of the bus, and you're walking at 2.0 meters a second, which I think is pretty fast, so good on you. That was a fast walk. Good hustle. What is the velocity relative to a person standing on the side of the road? Well, in the bus, or watching just the bus, you would see a bus moving at 20.0 meters a second. That makes sense. So the velocity of the bus relative to the outside viewer is going to be 20 meters a second. But inside of the bus, relative to the bus, you are moving 2.0 meters a second, and the bus appears to be still to you. You don't feel or perceive the bus is moving at all. So from the frame of reference of the bus, you're moving at 2 meters a second forward. And the bus outside of it, from the outside frame of reference, is moving 20.0 meters a second. So you can combine those vectors together, the bus relative to the viewer and you relative to the bus added together will give you your speed relative to the viewer, to someone standing on the side of the road. So they will see you inside the bus. The bus is moving at a certain speed. It's moving at 20 meters a second, and you inside of it are moving faster than that. You are moving an additional 2 meters a second faster. So we would take our first vector going forward of 20 meters a second, and we would add our second vector of you moving 2 meters a second inside of it. 20 plus 2 is 22 meters a second. So that's a really simple, really easy example. I didn't feel the need to have to show you that on paper. The next example is going to need a little bit more of explaining, and we'll probably start kind of helping you figure out what we're talking about. So my next example is a boat is capable of traveling at a speed of 1.85 meters a second. Let's say you've measured it on completely still water. You know the boat can travel at 1.85 meters a second. What you're going to attempt to do with that boat is you're going to try to travel north across a river, and that river has a current speed of 1.20 meters per second to the west. With that information, on the boat, you're going to perceive yourself moving 1.85 meters per second. And just looking at the river, you're going to perceive the river moving at 1.2 meters per second. But collectively, and they're going to have different pointed vectors this time. One's going to be going up and the other one's going to be going to the side. Those vectors are going to add together to get someone who's on the riverbank what they will see the boat moving relative to someone watching. Standing outside of the river, they're going to see both of these speeds combined together. So with this information, we want to figure out what will be the velocity in relation to someone on the shore. So we'll need to know the velocity and the direction. So we're going to figure out a decimal to go with it, or a degrees to go with it. If the river is 110 meters across, how long will it take to get across the river? How far downriver will the boat travel? And what angle would you have to launch the boat at in order to travel straight across? So this is a whole bunch of information, but this will give you the ability to basically solve every type of relative velocity example that I'm going to give you in class and on the test. You'll be pretty prepared once we've done all of this. So this is the end of this video. Click below. There's going to be attached to this a video of me actually working out this relative velocity example. That's all I got for this. In the meantime, I'll see you in a moment when you watch that video. Have a great rest of your day, everybody.